When NASA's New Horizons spacecraft reached Pluto on July 14, 2015, it marked a groundbreaking moment in space exploration. For the first time, a human-made probe had entered the distant realm of the icy dwarf planet. This mission was poised to transform our understanding of Pluto, a world long dismissed as a dim, frozen rock lurking at the edge of the solar system. But New Horizons revealed something far more fascinating. Pluto is a stunning cosmic landscape filled with complex geology and jaw-dropping surface features. So, what exactly are the strange formations that lie on Pluto's surface? And could it be possible that life once existed, or even still exists, on this harsh, frozen world? Stick around to discover the remarkable secrets Pluto has already unveiled. Pluto's story began on February 18, 1930, with a truly sensational astronomical breakthrough. On this day, American astronomer Clyde Tombaugh discovered the distant body, adding a new chapter to our understanding of the solar system. Yet the name Pluto has its own curious origin. When the Lowell Observatory invited the public to suggest names, it was an 11-year-old girl from Oxford, Venetia Burney, who proposed naming it after the Roman god of the underworld. Her suggestion struck a chord, and Pluto has carried that name ever since. Although the term planet has become somewhat flexible over time, especially since Pluto was officially removed from the list of recognized planets in August 2006, how exactly did that happen? The explanation is fairly straightforward. As astronomers discovered more Pluto-like bodies in the Kuiper belt, the International Astronomical Union chose to redefine what qualifies as a planet. This move was meant to avoid a situation where the solar system would suddenly have dozens or even hundreds of planets. Under the new definition, a celestial body must meet three criteria. It must orbit the Sun, be roughly spherical in shape, and have cleared its orbit of other objects. It was this last requirement that disqualified Pluto and led to its reclassification as a dwarf planet. Interestingly, when NASA's New Horizons spacecraft launched into space on January 19, 2006, Pluto was still considered the ninth planet. But by the time it arrived, after traveling the nearly 5.9 billion kilometers from Earth over the course of 9 years, Pluto's status had already changed. It's important to note that the distance between Earth and Pluto changes significantly due to their elliptical orbits, ranging from just under 4.3 billion kilometers to as much as 7.5 billion kilometers. One thing that remains constant, however, is the vast difference in size between the two. Earth has a diameter of approximately 12,740 kilometers, whereas Pluto measures only about 2,377 kilometers across, making it even smaller than our Moon. Consequently, Pluto possesses just 0.2% of Earth's mass. When it comes to temperature, though, Earth is clearly much warmer. Pluto is primarily composed of rock, covered by layers of water and nitrogen ice. Temperatures on its surface plunge to an average of -232 degrees Celsius, mainly due to its extreme distance from the Sun. To put that in perspective, sunlight takes roughly 5.5 hours to reach Pluto, compared to just 8 minutes and 20 seconds for Earth. Pluto, the dwarf planet, lacks a dense atmosphere capable of trapping heat or producing a greenhouse effect. What it does possess, however, is a small group of moons. To date, 5 have been identified, with Charon being the largest by far. Remarkably, Charon is over half the size of Pluto, measuring 1,212 kilometers in diameter. Because their shared center of gravity lies well outside Pluto itself, many astronomers consider them a binary system, aptly named the Pluto-Charon binary. This unique pair also exhibits a rare phenomenon in our solar system, mutual tidal locking. In other words, Pluto and Charon always show the same face to each other as they orbit, a feature not seen in any other planetary moon system. From massive heart-shaped regions to strange ice volcanoes, NASA's New Horizons mission unveiled Pluto as a world full of surprises. When the spacecraft became the first in history to reach Pluto on July 14, 2015, it sent back stunning images that defied all expectations. One of the most iconic revelations? Pluto literally has a heart, clearly visible in the photos returned from the distant edge of our solar system. Pluto's surface features the remarkable Tombaugh Regio, a vast, heart-shaped expanse made primarily of frozen nitrogen ice. This striking region reflects an unusual amount of sunlight, making it stand out dramatically. Within the western half of this heart lies Sputnik Planitia, a broad lowland spanning about 1,200 kilometers in width and 2,000 kilometers in length. Here, the nitrogen ice has formed thick, sharply defined patterns. But what's the origin of this unusual formation? While the heart shape might appear poetic at first, its backstory is far less gentle. Scientists believe Tombaugh Regio was formed when a massive object, around 700 kilometers wide and composed of ice and rock, collided with Pluto's surface at a diagonal angle and relatively slow speed. Adding to Pluto's dramatic landscape are substances ejected from its volcanoes. However, these aren't traditional fire-spewing mountains. Instead, Pluto experiences cryovolcanism, a rare phenomenon where ice and other frozen materials erupt rather than molten rock. Thanks to images captured by the New Horizons spacecraft, we've learned that despite its great distance from the Sun and its frigid environment, Pluto remains a surprisingly dynamic and geologically active world. Pluto features flowing glaciers, ice flows shaped by convection currents, and winds driven by the release of frozen nitrogen from the region known as Sputnik Planitia. When it comes to cryovolcanism, or ice volcanism, the New Horizons mission captured images of dome-like mountains with central pits that closely resemble traditional volcanoes. Two especially impressive examples are Wright Mons and Picard Mons, towering around 4 kilometers high and stretching up to 200 kilometers across. But in classic Pluto fashion, these giants don't erupt with molten lava. Instead, they likely release frigid materials like water, ammonia, or methane. Scientists believe that some internal heat still lingers beneath Pluto's surface, possibly generated by radioactive decay. This residual warmth may be just enough to keep water-ammonia mixtures in a liquid state deep underground. These fluids could then rise through cracks or fissures, behaving similarly to magma in Earth's volcanoes. What makes this even more remarkable is that evidence of such cryovolcanic activity suggests Pluto might not be geologically dead after all. And here's the real twist, there may even be a hidden subsurface ocean of liquid water beneath its icy crust. Pluto's thick icy shell may be hiding a remarkable secret beneath its surface. While this hasn't been definitively proven, there is compelling evidence pointing in that direction. Researchers believe that tectonic stretch marks observed by NASA's New Horizons spacecraft indicate that Pluto once experienced global expansion. When combined with thermal models, these geological features strongly suggest the presence of a vast subsurface ocean. But how could such an ocean exist in the frigid outer regions of the solar system? Wouldn't it have frozen solid by now? Not necessarily. Scientists propose two key factors that could be keeping this hidden sea from freezing. First, residual heat from radioactive decay may still be warming Pluto's interior. Second, an insulating layer of methane hydrate could help trap that heat, maintaining the ocean in a liquid state. There's also another intriguing possibility. Early in Pluto's formation, collisions with planetary building blocks might have provided enough heat to keep water in liquid form. In this scenario, Pluto may have started its history as a warm world with liquid oceans, slowly freezing into the icy dwarf planet we see today. If Pluto truly harbors a liquid ocean beneath its surface, it leads to a profound question: could it support life? After all, stable, liquid water is considered one of the essential ingredients for the emergence of life. We must remember that the suspected subsurface ocean on Pluto is likely not composed of pure water. Instead, it's believed to be a mixture of water and ammonia. Much like antifreeze, ammonia lowers the freezing point of water, allowing the liquid to remain stable in Pluto's extreme cold. Additionally, this ocean may contain other substances, such as methane, carbon monoxide, or salts, which would further alter its physical characteristics. The truly fascinating idea is that, in theory, this strange and icy world might be capable of supporting life.